So now we have a problem, one of the most difficult ones that you're gonna face, and well, you actually need to settle it like in the best way, and it will be very easy to solve. Okay, so the first thing you need to know is that both of these blocks are just like there, and you need to find first of all the static friction coefficient, and that's the first thing you need to find. Okay, so we need to first set the free body diagram of both guys. We have one thing over here that's going to be the tension, another guy on the other direction that's going to be the friction force, depending static or the dynamic according to case. We have a normal force going up and the weight going down. Okay, now for the mass 2, we have upwards, we have just the tension, and downwards we have the weight. Okay, so there we go. From there, we need to find the equations for x and y for object 1. I'm going to call this 1, and this is going to be called 2. So for 1, um, here it's the sum of all the forces in x, and this thing is going to be the tension minus the friction force. In this case, it's going to be the static force, and this is going to be equal to 0. And for the y-axis, it's going to be the sum of all the force. Well, no, number 2, no, let me erase that. That shouldn't go there. There you go. Sum of all the forces in y is going to be equal to the normal force minus the weight, and that's going to be equal to 0. Now, for the second object, we have that we have no forces in x, but we have in y, so the sum of all the forces in y is going to be the tension minus the weight, but this is like 1 and this is 2, and it's going to be equal to 0. Okay, so well, we basically can know, we need to find first the tension and the normal force. Why is that? Well, because I need the tension can be like here, I find it here, and the normal force is gonna be just here. Okay, so we need to, well, I'm gonna just solve for t in the x equation from the second mass. So the tension is gonna be equal to mass 2 times gravity, and the normal force is gonna be mass 1 times gravity. Okay, there it is. So then we substitute into this formula over there, and we know that the tension is gonna be equal to the static force, friction, and well, this is gonna be like mass 2 gravity. It's equal to the mu s m1 gravity. We just see like there's like gravity over here and gravity over here, so we have like mass 2 over mass 1. This is gonna be equal to mu s, and well, this could be like 5 over 7, and this is gonna be 0.714. Remember that the coefficients have no units. Okay, so that is part A. Now, for part B, we need to find the acceleration with which the blocks move. So we need to redefine our equations. Well, basically they're the same, but as the object's gonna move, there's gonna be equal to mass times acceleration. So therefore, the sum of all the forces in x is gonna be once again the tension, E tension minus the static force, no, kinetic, sorry. But this is gonna be equal to mass times acceleration because this thing is moving. The sum of all the forces in y is gonna be the normal force minus the weight, and it's gonna be equal to 0. And well, finally, we need to, for the second one, we need to select all the forces in y because there is no x. It's gonna be the tension minus the weight, what's gonna weigh 2, this 1. This is gonna be equal to mass times acceleration, mass 2 acceleration, but it's gonna go down, therefore it has a negative sign. Okay, so there you go. So from here, well, we need to find the acceleration. Yeah, acceleration. So, well, we need to find somewhere to substitute everything, and I'm gonna substitute everything here. So from the second equation, I'm just gonna say that tension is gonna be equal to mass 2 gravity minus mass 2 acceleration, and the normal force is gonna be equal to, I hate how I do F's, the normal force is gonna be mass 1 times gravity. Okay, for there. Now I'm gonna plug all those equations into the first one, x. So I know that this thing is gonna be mass 2 gravity minus mass 2 acceleration minus mu k mass 1 gravity, and this is gonna be equal to mass 1 acceleration. Okay, so from there, things are gonna get a little bit nasty, but I need to just solve for it. So I'm just gonna have gravity mass 2 minus mu k mass 1. This is gonna be equal to acceleration mass 1 plus mass 2. So acceleration is gonna be equal to gravity mass 2 minus mu k mass 1 all over mass 1 plus mass 2. And well, we substitute values. We know that gravity is 9.81, mass 2 is 5 minus 0.54, mass 1 at 7. I'm just missing a parenthesis there. So this is 5 plus 7, and this is going to be equal to 0.997 meters over second squared. And there you go.